Swayam Prabha. Digital India. Educated India.
Welcome back, everybody. We're going to do a little bit more practice with a little higher order complexity here, okay? Now I know you're thinking, what's all this chicken scratch about? Well, this chicken scratch is all the possible side chains, not all, but at least for 5 carbons, the possible side chain configurations. And we are going to see how we can name them in a simple way, some of them at least, and in the complex nomenclature method. So there are 2 methods. Let's talk about the simple way first. What is the simple way? Simple way is calling a spade, a methyl. This is 1 carbon. So this is the simple in the pink, methyl. And the complex also would be the same here because there's no branching. Ethyl, and we've done this before, 3 carbons, propyl. There's no other way to name them. And here's N-butyl, N-pentyl. No branching. Here's a branching. There's 2 ways to name a branching substituent or branched substituent. One is if it is a Y-shaped, it's iso, and then you put the number of carbons, 1, 2, 3, propyl. No hyphenation, and you alphabetize using the I. What is the other way? The other way is because when you get more and more complex side chains, it's hard to just give a name to it. Just like when you have longer and longer chains, you can't just call it by one name because it's got so many things sprouting out of it. So therefore, we take the substituent and have a rule for naming that as well. Here, that longest chain is 2 carbons. 1, 2. At the branch point, you have to start counting the longest chain. The rest are treated as side chains of the side chains. So here 1 has got a methyl. So this is 1 methyl ethyl. And you put that, let's say this is, let's say 10 or whatever. So you'll say 10 dash parenthesis. So you'll put the number of the locant or where it is in the chain. Dash. Parenthesis is almost treated like a letter. And then here is 1 methyl ethyl. And when you're doing alphabetizing of substituents in a complex nomenclature, you do it by the first letter. This rule doesn't apply. Di, tri, tetra, penta, all would be included in the alphabetic priority. You wouldn't do iso. So you would, this bis, tetrakis, tricase, and all of those you would include. Here is an iso group, 1 methyl ethyl. Now over here, this is 4 carbon and it's on the 2nd carbon, it's a secondary, so it's called sec-butyl, and these are both correct. And if you go in and try to order chemicals, you would see these on the bottles. But there is another way to name it, and that is taking this as like the parent of the side chain. So 1, 2, 3. 3 is propyl, 1 methyl propyl. So you would put whatever the number it is attached to, and within the parenthesis you will put 1 methyl propyl. All right, and over here this is 1, 2, 3, 4 carbons, and it's a Y shape, so it's isobutyl, and you would alphabetize by the I. And I'm going to underline the letter by which it's alphabetized, so you know that that's the letter to use when you're alphabetizing. And here again, you This is 1, 2, 3. So the point of attachment is always the carbon number 1, no doubt about that. Then you take the longest chain and take the branch from there. So here second carbon has a methyl, so that's going to be 2-methyl propyl, and so that's going to be M. And here again 3 carbons, and this is a tert butyl. I mean, it's a quaternary carbon, but it's a tertiary center, tert butyl. Okay, just taking that would be tertiary. So here again, same thing. This is the longest chain is 2 carbons. On 1, you have 2 methyls. So it's 1,1-dimethyl ethyl, 1,1-dimethyl ethyl. And here's the weird part about this. When you're alphabetizing, it's by D. Over here, this is now you've done all the 4 carbons, you've gone to the 5 carbons. What are the possibilities? You can have them straight chain like this, or you can have this methyl group branching in like here or here or here. So those are the possibilities. So again, now you can see how this simple naming is not simple anymore. So it gets a little bit more complicated here. This is neopentyl. Okay, great, we know that. But what about these? So then you can see how when you go to 6 carbon, it's almost like isomers. You got so many possibilities, and you can't just call them by names, iso, this and that, because they have a couple of isos now. So it gets way too complicated. So therefore, you're going to have to name these by the complex rule. So there again, you take the chain, the point of attachment is 1, the longest chain is 4, 1-methyl butyl. And M. Here, the point of attachment is 1, 2, 3, 1, 2-dimethyl, 2-dimethyl. Again, how do you alphabetize? Propose the longest chain. D. I know it's weird, but that's how it is. So the point of attachment is 1, 2, 3, 1,1-dimethyl. This is 1,2-dimethyl. Here they're both in the same carbon. 1,2-dimethyl propyl. So if both of these are dimethyl and 1,1-dimethyl, so how would you then alphabetize, find the alphabetic priority between these two, because the names are pretty much the same. And so if that's the case, this is dimethyl propyl, then you put 1, 1 before 1, 2. Three from the point of attachment, 2,2-dimethyl propyl. So that you can see why you need this complex naming when you get to bigger and bigger side chains. And then D. You can also have like this, cyclopropyl, 1-cyclopropyl. Or let's say you can have a methyl here or methyl here, and let's say you have 1,2-methyl cyclopropyl. Now, if your methyls here, you would name it 1-methyl. If you have 1,2-dimethyl, and so on, or cyclobutyl, cyclopentyl, cyclohexyl, you can go on and on and on. But you get the point, right? Point of attachment is 1. Then you find the longest chain. If it is a ring like this, then you find the cyclo ring. Then you number the substituents, give them the lowest number possible. Then you name it. And when you alphabetize it, you use the first letter inside the parenthesis. Over here, let's do one here. Where do we start? Do we start left to right like you read a book, or do we start somewhere else? Well, let's check it out. What's the longest chain? Is this the longest chain? Well, this is kind of coming down, so we have to see 1, 2, 3, 4, 5 carbons from this junction. 1, 2, 3, 4, 5, 6. So obviously this is longer than this. So don't get fooled by how the structure is written, because there's no rule that you have to write the hydrocarbon out so the longest chain is horizontal. There's no rule. I wish they had, but they don't. So you can write it any way you want. From this junction, it's going down. So then from over here, you can go 1, 2, 3, 4, or 1, 2, 3, 4, 5. Obviously, 5 is going to be longer than the 4 route. So we know this is our parent. And then we won't go here because this has got more interesting things. So 1, 2, 3, 4, 1, 2, 3, 4, except this is kind of bland. There's nothing to see there, just desert there. Over here you got trees and streams and springs, and so a lot more to do here. Go this way. If you go this way, you're going to miss out on that extra leg of the journey. You paid for it, so let's go the extra mile and get to the very end. So this is our longest chain. Next is where you start numbering. Do you start numbering 1, 2, 3, or 4 and so on, or 1, 2, 3, 4 and so on? Well, look at the rules. It says longest chain, maximum branches. We did that. Number the parent to give the lowest number to the first substituent. There you go. So here you're hitting your first substituent on 3. Here you're hitting your first substituent on 2. So this is not the way to go. You want to do it early in the morning when it's still kind of nice and cool out there. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Using these rules. The major challenge is to figure out the parents. Numbers are the same, assign alphabetic priority. Actually, the numbers are different, so we don't have to worry about that rule. Each chain is either part of the parent or the substituent. We know that. So we won't count this for the substituent. We only count the substituent from here, and so on. So let's see who the substituents are. On 6, you have 1, 2, 3, 4. So that's an N-butyl. 3 is an ethyl. 2 is a methyl. And 8 is a methyl. So that's 2, 8 dimethyl. And 7 is an isopropyl. 7, I'm going to write it here, 7 isopropyl. Or 7 can be named as 1-methyl ethyl or 1-methyl ethyl. Now they both have different alphabetizing. I for one, M for the other one. And here is M, here's E, and here's B. Obviously, we're going to start with B. 6, let's go. 6 N-butyl. And then you're going to have over here ethyl, and then your isopropyl, and then your methyl. So 3 ethyl. This is their simple naming. And then you're going to have your isopropyl, 7 isopropyl, and dash, I'm just writing it over here, 2,8 dimethyl. And then your parent is a decane. No space. Okay. There's no space between substituent and parent, nothing. It's just like waste space on that catalog, right? So we got that. You can do the other one where it's going to be very similar for all of them are going to be the same except your isopropyl where you put one methyl ethyl. So you will do N-butyl, ethyl and methyl and then one methyl ethyl. I guess in the telephone directory it's John and then Johnson, so methyl then methyl ethyl. It's just like in the alphabetic rules that you have. So here we can do 6 N-butyl, 3 ethyl because this is going to be the same naming for both, and then 2,8 dimethyl, and then 1 methyl ethyl, and that's on 7. So then that is 7 dash 1 methyl ethyl. Parenthesis close, and no dash after this because this is kind of like part of the letters, and the parent would be the same. The parent will not change for the complex or the simple because we are going to use the same rules. Let's do a cyclocompound. So here's our cyclocompound. Where do we even begin? Do we begin with methyl, isopropyl, bromo, or T-butyl? Well, first give the lowest number by alphabetic priority to cyclocompounds. First of all, 6 is the highest number, so this is a cyclohexane. So Br, bromo, and butyl or T-butyl would be kind of the contenders here for first place. So B and B same. R before U, so you give number 1 to this. Then you would number the rest of the chain so the other groups get the lowest possible numbers. So you go down 2, 3, 4, 5, 6. Now you can number this both ways. You can number this with the complex or the simple. If you do simple, you're going to do isopropyl and then methyl. So you're going to do 1 bromo, 4 T-butyl, isopropyl, and then methyl, right? So you're going to name them according to alphabetic priority, alphabetized substituents, parent and substituent. Same rules, we don't change the rules. 1 bromo, you don't even have to write the 1 bromo, and then T-butyl would be next, 4 T-butyl. You don't have to put you can put T. Then it's going to be 6 isopropyl, I before M. And then it's going to be 2, 2, 3 trimethyl, dash 2, comma 2, 3 trimethyl, because they're alphabetizing with M, and cyclohexane. So let's do the complex now. Pretty much, very similar alphabetic priority for numbering. So here, this is going to be 1 methyl ethyl. This is going to be 1, 1 dimethyl ethyl. So, and these are methyl. So here the only difference is this is D and this is M. So we're going to do bromo, then the dimethyl ethyl, then the methyl ethyl, and then, then the methyls, and then you will end your name. So this is going to be 1 bromo, and you're going to do 1, 1 dimethyl ethyl because you're going by the first letter inside the parenthesis, and you have to say it's on 3, so you'll have to put the locant number and then you're going to put the parenthesis and 1,1-dimethyl ethyl, 2,2,3-trimethyl. Then after this you're going to put a number, so you'll have a dash after that, and you continue there. I'm just writing it here, 2,2,3-trimethyl, and then 1-methyl ethyl on 6, so 6 parenthesis and 1-methyl ethyl. And then the parent is going to be the same because we are just counting the ring parent because that's got the most number of carbons. And again, if you feel like, oh, where's the number here, you can go ahead and put the number there. That's fine. All right. So I'm just showing you two different IUPAC ways of numbering. As you get more and more complex things, it's better to use the complex form of numbering. One more, guys. I know this is crazy and you think I'm losing it. Maybe I've already lost it. I'm not sure, but let's finish this. Left to right, right to left. Think about it. Hit the pause button and then tell me which way. If I go this way, 1, 2, 3, before I hit the first lookout point. If I go this way, I have two choices. 1, 2, 3, 1, 2, 3. Does it matter? No, it's symmetric. It doesn't really matter. They're just like exactly like a mirror image of each other. You go here or here, it doesn't really matter. So let's go 1, 2, 3 or 1, 2, 3. It doesn't really matter. And then you got to go 4, 5, 6. And so this is not correct because it's taking too long for you to see anything interesting. 9, 10, 11. So 3's got an isopropyl, 6 N-propyl, and this is going to be a methyl. So this isn't as complex as it looks. So let's do N-propyl versus isopropyl. Which one is going to be first? So this is N-propyl is P. This is isopropyl is I. So this is important, guys, because that kind of trips you up sometimes. Okay. So isopropyl is going to be before P, propyl. Then this is methyl, which is going to come in between the isopropyl and the propyl. So 3's got an isopropyl, then 2, 5, 9, 9. You got 4 tetramethyl. So 2, 5, 9, 9 tetramethyl. And then we have an N-propyl, 6 N-propyl. And then who's the parent? Undecane. So there you go. That's how you name it. All right, guys. So hope you have a better understanding of how to do naming of these long chains with all these complex rules. They get simpler as you practice, and we'll come back for more when we meet next time. Talk to you soon. Bye.